Okay, in this video I'm going to explain the relationship between the temperature of an object and the kinetic energy of particles within it in terms of physics. Okay, so this is Waves in Thermodynamics Module 3. I've done Module 1 and 2 already on my YouTube channel, so please subscribe and check it out for kinematics and dynamics. So let's have a look here. Temperature is a measure of the average kinetic energy of the particles of matter. The kinetic particle model states that all matter is made up of small particles. You may have learnt this in junior science about solid, liquids and gases. These particles are always moving except at absolute zero, which is defined as the temperature at which all particle motion ceases. The particles are held together by forces which vary in strength. No kinetic energy is lost or gained overall during the collision between particles. There are no forces of attraction or repulsion between the particles in a material. The distances between the particles in a gas are large compared to the size of the particles. And you can see that by adding energy from a solid to a liquid, it then turns into a gas and they spread around and have more kinetic energy. And if we remove energy from a gas to a liquid, then you can go then towards a solid and you can get in a fixed state. Okay, so you can use a bit of your year 7 to 10 knowledge for this concept here of thermodynamics. So I've got here now a slide which has the first half of a sentence and the second half of a sentence. And if you like the opportunity to sort out these answers, you just need to match the first half to the second half. You can pause the video now. Now I'm just going to go through those answers on the first half and the second half to discuss the concepts of kinetic theory of matter. So you should see now the answers appear in green. So all matter is made up of particles which are in continuous motion. The particles of matter are always moving except at absolute zero, and I've said that in my previous slide. And the particles in matter are held together by forces which vary in strength. And the particles in solids cannot move freely because they are held together by strong forces. Particles in solids simply vibrate in their fixed positions, and that's given off as thermal or heat energy. And in liquids, particles can roll over one another. The forces holding particles together in liquids are weaker than those holding particles together in solids. Particles in gases are free to move in any direction so that the gas always fills their containers or balloons if you're having a party. 9 particles in gases are not held together. 10 particles of matter are far too small to be seen even underneath a microscope, and we deduce the behavior of particles of matter by studying the properties of matter, and we use the kinetic theory of matter to explain and predict the behavior of matter. Okay, so now you should see another first and second half sentence question here where you need to correctly match those two together. But this is in terms of temperature and the kinetic theory of matter. So if you'd like the opportunity now to pause it. Okay, you should see the answers now appear up with green. So temperature is a measure how fast the particles are moving. The temperature is a measure of the average kinetic energy of the particles of matter. The higher the temperature, the faster the particles are moving from one another. And when matter is heated, the particles absorb energy and move faster. 5, when the matter is cooled, its particles lose energy and slow down. Gas particles have more energy due to their state than liquid particles at the same temperature. Similarly, liquids particles have more energy than solid particles at the same temperature. And in both cases, 6 and 7, this is due to the extra energy they have because particles move more freely. So on a hot day, the particles in our air are moving more rapidly than on a colder day. You may have learnt this already in junior science, but this is a bit of a revision in thermodynamics. I've got another one here where you need to do the same concept, match the first and second half of the sentence. And this is looking at states and the kinetic theory of matter. So if you'd like the opportunity now to pause it, and you'll see now that the answers appear up in green. So as a gas is cooled, its particles move more slowly. As the particles lose energy, the forces between them can still hold them together. Eventually, the strength of the forces between them, the particles, is strong enough to hold them close together. you've got here, they start to form a lattice but are still able to roll over one another. As more energy is removed from the system, more particles move in lattice positions. Eventually, the system loses sufficient energy for all particles to become bonded in the lattice, and the gas has condensed and become liquid. Okay, so this is just matching, it's a bit of a literacy exercise here, matching the first half to the second half of the sentences. And we just touched on state, temperature, and the kinetic theory of matter in these first half of the sentence and second half of the sentences questions. Okay, this was just an introduction of thermodynamics, looking at this particle theory, looking at how temperature affects that and kinetic energy of these particles. Okay, so basically temperature is a measure of the average kinetic energy of the particles have, and you would have learned some of the models or the concepts that I've discussed in this video in your 7 to 10 science courses. Alright, if you already haven't, please subscribe. I'm going to continue with thermodynamics, so we're going to move on from explaining the relationship of temperature in my next video. Thank you.